Today what we're going to learn about is nothing but change of state. Okay, so we have learned yesterday three different state of matter, that is solid, liquid and gases, and we've also learned their properties based on the arrangement of molecules in the molecular level, as well as their different physical properties in that particular state also, right? Okay, so now the question is, can a substance be converted from one state of matter to another? Can a substance which is in liquid state be converted into gaseous or solid? And so on goes for other state of matter as well, right? Okay, so that is the question today, and we are going to have the answer of that question today itself. Okay, so what we're going to talk about today is what? It's change of state. Okay, and this might be the second last lecture for today, for this lesson to be completed, and we hope so that I hope so that all of you students might be understanding all of the things that I'm teaching you very thoroughly. Okay, so we'll get started with the lecture. Okay, so change of state of matter. So we'll see what we have in this topic, under this topic. Okay, so let's see. Now let us have an example. Okay, so if we talk about water, okay, so water can be like briefly available in all of the three sets of matter. If water is cooled down, we can get ice, which is solid in state. If it is brought to room temperature, it will be liquid in state. And if we raise the temperature, so it will be converted into steam or vapors, which is gaseous in state, right? So water can be converted into any of the state of matter, right? It can be either solid, liquid, or gases, right? So ice can be converted into water, and water can be converted into steam. Okay. Similarly, what we can say is gas can be brought back into liquid, and can be brought back into solid as well. So if you see, the cycle is the change over here is reversible, and it can be reversible very easily. आराम से हम लोग इसको अच्छी तरीके से reverse कर सकते हैं, right? Okay. So now the question is, how can that be possible, and what is the thing which is responsible over here, right? Let's see. आगे देखते हैं. What happened inside the matter during this change, right? The question over here is what? That why does this material, or does the state of matter changes, and what is the factor which is responsible for doing that, right? Okay, so let's see. So what happens to the particle of the matter? That's another question. And how does this changes of state takes place? ये होता कैसे है, right? So these are the questions that we are going to have answer to in this lecture. Let's see. Now, change of state में यहाँ पे देखो क्या बोलता है. A phase or state of matter can change when the temperature changes. Okay, so the state of matter can change when the temperature of the matter of the substance tend to change. Okay, so आप किसी चीज को गर्म या ठंडा करोगे, what will happen is it will change its state. Okay, most of all, cooler things tend to get solid state, and hotter the object, it will be moving towards the gaseous state. Okay, moving on, आगे देखते हैं. So each addition of energy creates a change in state. Whenever you add energy to it, what will happen is the state of the matter tend to change. आगे देखते हैं. Okay, so if you have solids, okay, if you have solids, and if you're increasing the energy, if you're applying energy, what will happen is they'll be converted into liquids. Okay, and on liquids, if you apply more amount of energy, what will happen is they'll be converted into gases. Okay, so solids, when you apply energy, that will be converted into liquid. On applying energy to liquid, that will be converted into gases. Okay, so you will ask, sir, what kind of energy are we talking about? So it's heat energy. Okay, so once we apply heat energy, what will happen is the kinetic energy, the particles inside inside the substance will increase. Ultimately, that will lead to the increase in the distance of particles, which will create huge intermolecular spaces. And we've already learned, the more the intermolecular spaces, the more it will be converted from solid, then it will be from solid to liquid, or from liquid to gases. Okay, so each and everything is only the play of what? It's the play of intermolecular spaces. So by applying heat energy, what happens is we're simply increasing the kinetic energy of that particle. Let's see. Let's see. As temperature rises, matter moves to a more active state. Okay, so which one is the most active state? It is gases. Why? Because we have seen that the particles of gases move very much freely, right? So in that state of matter, the particles become very active, right? So if you compare with liquids, so liquids are lesser active as compared to gases, and in solids the activeness is the least. Correct? Moving on, like that. Total happiness. The change in state of matter is governed by kinetic theory of matter. Okay, so who governs the change in state of matter? कौन इसको control करता है? कौन इसको govern करेगा? Okay, so there are these three properties of particles. What? The space between the particle, the force of attraction between the particle, and the kinetic energy of the particle. So if we alter or change any of these things, what will happen? We'll get a new state of matter. Okay, moving ahead. So now, for example, if we see, if we take a vessel and we put some ice cube inside it, we see that the ice cube is in solid state. But as soon as we apply heat energy into it, what will happen is it will be converted into what? It will be converted into liquids, right? Yes or no? So we have over here solids, and solids have particles that are very close, so very much close to each other, right? Correct? Yes or no? Likewise, when we heat it up, what will happen is that will be converted into what? It will be converted into liquids. Why? Because on application of heat energy, what will happen? Those particles which were very closely packed to each other, now they are moving further apart. And what is the reason behind that? Because you are increasing the kinetic energy of that particle. Okay. So it turns into liquid and particles move away from each other. Okay. So if you still heat it up more, what will happen is that it will be converted into steam. You will get steam or you will get vapors, correct? So you'll start getting vapors or steam out of it, correct? So now what we can say is the liquid is being converted into gas, and upon doing that, what happens is the particles move more further apart from each other. Okay, so it's all about what? It's all about the increase of kinetic energy and increasing the distance between the particles, or increasing the intermolecular distances, right? Okay, so once doing that, what we can have is we can have multiple different state of matter. Okay, so now what we'll do is we'll talk about temperature, because since the temperature is responsible to change the state of matter, what we need to do is we need to learn about temperature at the first place. Okay, so what we'll do is, okay, again, so how can you define temperature? So temperature is nothing but it is a measure or magnitude of hotness or coldness of a substance. मतलब एक सब्सटेंस कितना गर्म है, ये कितना ठंडा है, उस चीज को हम लोग क्या कहते हैं? दैट इज कॉल्ड एज टेम्परेचर. ओके, सो नाउ the temperature can be measured in three scales. What do you mean by scale? Scale is nothing but units. So we can use either of the three units for measuring temperature. Okay, what are these three units? The first one is Celsius. We call it as degree Celsius. The second one is Kelvin, and the third one is Fahrenheit. Okay, so what we can do is Celsius is the most common scale that we use in our day-to-day life. Okay, like measuring the temperature of the atmosphere, or measuring the temperature of any solution inside a vessel in chemistry lab, and so on, right? So Celsius, degree Celsius, is the most common scale that we use in our day-to-day life, and it was invented by a physicist whose name was Andreas Celsius. So the unit's name Celsius is after his name Celsius. Okay. The next one is Kelvin, and it is represented by capital K. Okay, and that's the SI unit. SI unit stands for Standard International Unit. Okay, so whenever you're supposed to calculate heat energy in your physics part, at that time calculating it in kelvins is a standard followed by physicists internationally. Okay, and that was like discovered or formulated by Lord William Thomson Kelvin, and again after his name, the name of the unit was there. Okay, and then the next one is Fahrenheit, which is also called as a doctor's scale. Okay, so most of all, doctors use the Fahrenheit degree scale, and that was formulated or invented by Gabriel Daniel Fahrenheit. So these were the people who are responsible for making these three different scales to measure the temperature. I hope so you've understood it. Let's move on. आगे देखते हैं. Another thing is, now let's talk about Kelvin scale. Okay, so temperature at which gas is cooled to obtain zero volume. Okay, now Kelvin scale क्या होता है? It is the minimum temperature. वो temperature होता है कि वहाँ पे गैस इतने छोटे हो जाते हैं, इतने छोटे जगह पे कंप्रेस हो जाते हैं कि उसका वॉल्यूम क्या हो जाता है? जीरो. बट ऑब्वियस आप बोलेंगे सर ये कैसे पॉसिबल है? हम गैस को अगर लेते हैं और उसे एकदम छोटा भी कर दे, बट स्टिल इट विल टेक सम स्पेस. द वॉल्यूम विल नेवर बी जीरो. करेक्ट? यस और नो? ओके, कोई भी चीज होती है, उसका कोई भी चीज जिसके पास मास है उसका वॉल्यूम जीरो नहीं हो सकता है. So even if it take few gas and compress it to a very small place, still there will be some or the other volume. It can never be zero, right? So what's the next point? That is called as absolute zero or zero Kelvin. Okay, but that's not possible, right? Such a volume and below are not practically possible to obtain. ऐसे वॉल्यूम को प्रैक्टिकली ऑब्टेन हम लोग नहीं कर सकते, राइट? ओके, so we cannot get a volume where gases can be broken or can be compressed so in such a small space that we can say that the volume is zero or the gas have reached absolute zero temperature, right? So hence all temperatures are positive. इस वजह से जितने भी हमारे पास temperature है, all of them are positive. So whenever we talk about kelvins, okay, so the temperature in kelvins is always positive and it is never negative. Okay, unlike अगर हम लोग डिग्री सेल्सियस यूज करते हैं तो वहाँ पे माइनस में भी हम लोग उसको कैलकुलेट कर सकते हैं. जैसे कि अगर हम लोग कश्मीर या शिमला के बारे में बात करते हैं तो इन स्टेट्स में कई बार जो टेम्परेचर बिलो 0 डिग्री गिर जाता है तो हम लोग बोलते हैं द टेम्परेचर ओवर देयर इज -8 डिग्री सेल्सियस और -10 डिग्री सेल्सियस. तो दैट इज हाउ Celsius can be represented in negative, but when you talk about kelvins is always positive irrespective to how much cold the substance is. Okay, आगे देखते हैं. Now, how can you convert Kelvin to Celsius? The formula is too easy. If you want kelvins, so if you want the unit to be converted into kelvins and you have it in Celsius, the formula that you will be using is kelvins is equal to 273 plus plus degree Celsius, the amount of temperature you have in degree Celsius. Okay, so this is how it is represented in your textbook. But if you want to be very precise, आपको एकदम accurate रहना है, so I'll give you another formula. Okay, that's very accurate formula. The formula is K is equal to 273.15 plus degree Celsius. That will be very accurate formula. Okay, so in your textbook it is mentioned in this way, and even if you use this formula, that will be very much fine. It's not an issue. Your marks will not be deducted. But still, for your knowledge, what I've did is I've given you very accurate formula to convert Kelvin to convert degree Celsius into Kelvin. Okay, let's see. आगे देखते हैं. So this is the formula that we can use. Let's see what's further. So numerical. Let's solve a numerical. I guess there will be a numerical in your textbook also, so you can have a look to that numerical once the lecture is completed, and you can solve it by your own since I am giving you the explanation for it. Okay. So let's see the numerical over here. So let's say we have a question that convert the temperature of 25 degrees Celsius to the Kelvin scale. Okay, so let's have given over here, right? तो हमारे पास solution में क्या आएगा देखो. What is the formula? So temperature on Kelvin scale will be equal to temperature on Celsius scale plus 273. That's the exactly same formula which I have given you right now. बराबर अभी just मैं आपको formula दिया था. क्या formula था वो formula क्या था यहाँ पे? It was K is, देखो यहाँ पे ये जो part हो गया ये K हो गया, and this part over here will be the C, and यहाँ पे हमारे पास क्या है 273. So what we can say is K is equal to C plus 273. And if you want to be accurate, what you can do is you can simply put 273.15, so you can get very accurate answers also. Okay, let's continue. आगे देखते हैं. So what you will get is, so temperature on Kelvin scale will be equal to temperature on Celsius scale. So Celsius scale में हमारे पास कितना value, that is 25 degrees Celsius. So what we will write is 25 degrees Celsius and we'll simply add it with 273. What you will get the answer is 298, and that will be the answer. So thus the temperature of 25 degrees Celsius on Celsius scale is equal to 298 Kelvin on the Kelvin scale. So that is how you can solve, or you can get temperatures which is in Celsius scale converted to or be modified to in Kelvin scale. I hope so you have understood it well. If you have any doubt or questions, you can simply put it in your comment section or chat section so that I can solve it right away. We'll move on. आगे देखते हैं. Then the next one that we need to learn about is what? Another numerical. So now let's say we have the inverse condition over here. The question is, convert the temperature of 300 Kelvin to the Celsius scale. Now we have the temperature in Kelvin scale and we need to convert that into Celsius scale. So what we'll do is, we'll use the same formula, right? So temperature on Kelvin scale is equal to temperature on Celsius scale plus 273. But this time the only difference is we have the value of this side, right? So what we'll write is 300 is equal to temperature on Celsius scale plus 273. Okay. Now to get the answer, what we'll do is we'll simply shift 273 to that side. So since it is plus over here, it will be minus on the other side. What you'll get is temperature on Celsius scale will be equal to 300 minus 273. Once you minus it together, what you'll get is you'll get 227 degrees Celsius. So when you talk about 300 kelvins, that is equivalent to 27 degree Celsius. Okay, I hope so you have understood it well. So what we can say is, thus a temperature of 300 Kelvin to the Kelvin scale is equal to 27 degree on the Celsius scale. So this is how we can convert temperatures from Celsius to Kelvin or Kelvin to Celsius back. If you want to convert Celsius to Kelvin, you're simply supposed to add it with 273, and if you're supposed to convert it into degree Celsius, you're simply supposed to subtract 273 from it. Okay. I want none of you to get confused with this. It's very easy to understand also. Fine. Let's see what we have ahead. Now, what we'll do is we'll see effect of change of temperature. So if you change the temperature of a substance, how will it be affecting your substances or the state of matter? Okay, so let's see. So in interconversion of states. So what do you mean by interconversion of states? Something can be converted into liquids, can be back converted into solids again, and it same goes for other state of matter as well. Okay, so let's see what is that. So we have these three state of matter, and that is solid, liquid, and gases. Okay, let's learn about interconversion of state of matter. Okay, so what we have over here is that solids can be converted into liquids, and the process in a common language will be called as melting. We'll call it as melting. It is also termed as fusion in our scientific or in our chemistry language. Okay, it is also called as fusion. Why fusion? Because the particle of solids which were like held very closely to each other now are able to move a bit more freely, and that is why fusion takes place. And that is why we can say that solid have went to fusion state and have been converted into liquids. Liquids can be converted into gases, and that process is called as boiling or evaporation. क्या कहेंगे सुनो? We will call it as boiling or evaporation. Okay. Now again, solids can be converted into gases, and the process is called as sublimation. There are certain solids which undergo sublimation. It means what? That it will be converted direct from solid to gases without being converted into liquids. We'll be learning about this in the coming slides as well. Okay. Now, this was only the change of state of matter from one to another. How can we say that is interconversion? So we'll have the process backward also. So all of these things are reversible as well. Let's see about that also. So आगे देखते हैं. So gas can be brought back to liquids also, and this is called as condensation. क्या कहेंगे हम लोग इसको? We'll call it as condensation. Okay, and just because of condensation, the vapors which are formed by the action of sunlight on oceans, those vapors go high up in the sky. वो लोग sky में एकदम ऊपर जाते हैं, and they get condensed, leading to the formation of clouds also. Yeah, similarly, when your mom cooks food and she like covers the vessel with a lid, once opening the lid after a few minutes, you'll see the tiny droplets of water settled on the lid, right? That is also again due to condensation. The next one is liquids can be brought back to solids, and the process is called as freezing. Okay, so liquids can be brought back to solids, and this process is called as freezing. Okay, similarly, gases can be brought back into solid state, and that process is again called as sublimation. So, in case of solid to gases or gases to solid, both of the process will be called as sublimation. Sometimes the process of conversion of gases to solid is called as solidification. In some books or in some reference books, the term used over here is what? It is solidification. I'll just write it for you. It's solidification. Okay, so this is how we can say that in some books or in some references books, the term used for conversion, the process of conversion of gases to liquids is nothing but it is called as solidification. Okay, आगे बढ़ते हैं, देखते हैं. So what do we have further? So now we'll see effects of change of temperature, and let's see. So we'll see each process step by step. One by one हम लोग सभी steps को या सभी process को देखेंगे. So we'll talk about change of solid to liquid and the process called as melting. Okay. So to understand that, what is the definition? The process in which a solid state changes into liquid on heating is called as melting, or sometimes refers to as fusion. Okay. Now, the temperature at which a solid substance melt and change into liquid at atmospheric pressure is called melting point of a substance, and we've already learned this in 8th standard, that the temperature at which any substance melt, that temperature will be called as melting point. Correct? The melting point of water is how much? It is 0 degrees Celsius. So any temperature more than 0 degrees Celsius for water, the water will be in liquid state. And if it is in temperature lower than 0 degrees Celsius, if it is in negative side of temperature, so what will happen is this water will tend to be in solid state, that is in ice. It will be in the form of ice. Okay, let's see. The melting point of a solid is the measure of the force of attraction between its particle, atoms, or molecule. Okay, so what is melting point? It is the amount of force which is held between those two particles. दो पार्टिकल के बीच में कितना फोर्स है अट्रैक्शन का, जिसकी वजह से दोनों पार्टिकल एक दूसरे को साथ में पकड़ के रख रहे हैं. That amount of force is nothing but the melting point. Once we break that forces, what will happen is that these particles will move far away from each other. दोनों जैसे दूर हो जाएंगे. We already know that when particles move far from each other, that the state of matter changes, right? तो solid में बहुत पास में होते हैं, जब वो दूर जाने लगेंगे तो क्या हो जाएगा? वो liquid में convert हो जाएगा. Okay, आगे देखते हैं. So now let's talk about ice. So ice can be converted into water at room temperature, correct? So the melting point of ice is 0 degrees Celsius. The melting point of iron is 1535 5 degrees Celsius, right? So this is for the reason. If we talk about our room temperature is around 25 degrees Celsius to 28 degrees Celsius. So if we keep an cube of ice on our room, so it will be affected by room temperature and it will be brought to roughly around 25 degrees Celsius, which is more than 0 degrees Celsius, and ultimately ice cube will not be in solid state for a longer period of time when you keep it in open room. But if you take an iron nail or any other iron object, and no matter for how much time you keep it on open room, it will never melt. Why? Because our room temperature will never rise to a point as high as 1535 degrees Celsius, which is extremely hot temperature, right? And that is why the reason is that the water is liquid at room temperature and iron is solid at room temperature. I hope so you've understood this well. Let's see. The next process is liquid to gas, and the process is called as vaporization. Okay. So let's say what is vaporization. So vaporization can be done by boiling or it can be done by evaporation. Okay. So let's take an example of water. Water can be converted into steam on application of heat energy, correct? So let's see. The process in which a liquid substance change into gas rapidly on heating is called as boiling. ठीक है? यहाँ पे देखो क्या बोला है? The word rapidly is very important because evaporation is rather a slow process, right? So when you talk about changing of liquid substances into gas very fast, then that process will be called as boiling, and that is done by application of heat energy, correct? Okay. Next, the temperature at which a liquid boils and changes rapidly into gas at atmospheric pressure is called as boiling point of the liquid. Okay, so that amount of temperature at which the liquid boils and it gets converted very rapidly into gaseous state is called as the boiling point of that liquid, and the boiling point of water is almost, it is 100 degrees Celsius. Okay, boiling point of water is how much? It is 100 degrees Celsius. Boiling point of alcohol is 78 degrees Celsius. Okay, so if you try to like boil both of these liquids, water and alcohol together, what will happen is alcohol will tend to get evaporated or boil. It will tend to boil quicker as compared to water. Why? Because its boiling point is less than water. Okay, moving on. I get it. Now the next thing is gases to liquids. This process is called as condensation. Okay, so this was the reverse process of getting converted from gas to liquid, and this process is what the process of changing of gas or vapor to a liquid by cooling is called as condensation. What do we call it as? We call it as condensation, right? So whenever we have any kind of gas or vapor, if we cool it, if we cool it down, okay, so what will happen is that gases will be converted into liquid, and this process is called as condensation. Let's see what we have further. So a very simple and common example that you all might be aware of is the formation of cloud. We know that the sun, the heat due to the sun leads to the formation of vapors of oceanic bodies as well as other water bodies on our land. And that vapors tend to move upwards and they condense as they go higher on the sky, and they get converted into clouds. Okay, so this is an example of condensation. Condensation is the reverse of boiling. So in boiling, what would happen? Liquids were converted into gases. But in condensation, what is happening is that gases are converted into liquids. It's completely inverse of that process. Okay. So formation of steam. That steam can be converted into water by cooling it down. So the water cycle is also can be held only because of condensation that is taking place higher up in the sky. Higher up in the sky. I hope so you have understood everything properly till now. Let's move ahead, move further. See what we have is, in this process, water vapor formed due to evaporation rises high up in the high up. The temperature is low, so vapor condenses to liquid and forms clouds. Okay. it's the same thing that I've already explained to you. Moving on, आगे देखते हैं. So the next one is solid to liquid to solid, that is called as freezing, sometimes also referred to as solidification also. This is the process of changing a liquid into a solid by cooling. So even if you like cool it more, what will happen is that liquid will be converted into what? It will be converted into solids. Okay, and this process is called as freezing. Water, which is in liquid state, can be converted into cubes of ice by cooling it down. Freezing is the reverse process of melting, right? So in melting, what would happen is solid would convert into liquids. But when you talk about freezing, what is happening is liquids are converted into solids. So let's talk about latent heat of fusion, which is most important thing to understand when it comes to change of matter. Okay. So to understand this, we'll take an example. We'll do an experiment in which we'll have a beaker full with few ice cubes. Okay, so we have take some for the first step is take some crushed ice in a beaker. What we'll have over here is we'll have few ice cubes inside a beaker. एक beaker के अंदर कुछ ice cubes हम लोग के पास रहेगा. Okay, what we'll do is we'll suspend a thermometer inside it to measure the temperature of it. Temperature को measure करने के लिए रखते हैं. And so what we'll do is we'll simply put a thermometer inside it so that we can have a note of the temperature. So if we once we immerse the thermometer inside the crushed ice cubes, what we'll see is we'll know the temperature and we'll see that the temperature is 0 degrees Celsius, right? It's 0 degrees Celsius. आगे देखते हैं. So what we'll do is now heat the ice gently by using a small flame of the burner. So what we'll do is we'll not quickly heat it up. Rather, what we'll do is we'll heat it up very gently with a very small flame, okay, of a burner. हम इसे बहुत आराम से गर्म करेंगे, okay. Now what will happen is as long as there remains even a little of ice in the beaker, there is no rise in the temperature during the melting of ice. What you will see is that those ice cubes which were in solid state will be getting converted slowly into liquid state, but the temperature will not change. Why is it the temperature changing? Because the amount of heat energy that you're applying is completely getting used up for those particles to get far apart from each other, right? So just because of that, the temperature of the solution is not increasing. Why? Because the kinetic energy is not increasing. Why is the kinetic energy not increasing? Because the energy that you're applying is completely being used for increasing the distance between those particles, and rather than increasing the kinetic energy. And hence what we can say is till the time we have even a small piece of ice, the temperature of the solution or the temperature of water will remain 0 degrees Celsius. So the amount of heat energy taken for by this ice to get converted from solid state complete to liquid state without changing in its temperature will be called as the latent heat energy of fusion. Okay, so let's see what we have over here. The heat which is going into ice but not increasing its temperature is the energy required to change the state of ice from solid to liquid, that is water. This is known as latent heat of fusion of ice. What is this called as? Latent heat energy of ice. Okay, let's see. This latent heat of fusion of a solid is the quantity of heat in joules required to convert 1 kilogram of the solid to liquid without any change in temperature. Okay, समझ में आ रहा है? So 1 kilogram of solid which is at its melting point to liquid, right? So मतलब उसको melting point में होना चाहिए, 1 किलो का होना चाहिए, 1 किलो का मतलब आप जो भी मटेरियल की बात करें वो 1 किलो होना चाहिए. And इस amount of temperature हम लोग क्या कहेंगे? The latent heat energy of fusion. Let me explain it to you like more in detail. So जो for example आपके पास ice है और ice को आप लोग ने एग्जैक्टली मेल्टिंग पॉइंट के ऊपर रखा है बट स्टिल सॉलिड स्टेट में है, ठीक है। मेल्टिंग पॉइंट में रखा बट से अभी भी कौन सी स्टेट में है, सॉलिड स्टेट में ही है, करेक्ट। तो अभी उसका टेम्परेचर क्या रहेगा, 0 डिग्री सेल्सियस रहेगा। नाउ व्हाट यू आर डूइंग इज यू आर इंक्रीजिंग द टेम्परेचर, आप उसमें हीट डाल रहे हो, हीट डाल रहे हो, हीट डाल रहे हो, यू आर एबल टू सी दैट द solid ice is getting converted into liquid with time, with increase with more application of heat energy, but still the temperature is not changing, right? Yes or no? So until unless each and every ice cube gets converted into liquid, the temperature won't change. So that amount of heat energy required to convert the entire solid material into liquid material is called as the latent heat energy of fusion, provided that the amount of substance that we are talking about is 1 kilogram. Okay, so that will be the latent heat of fusion. Okay, so latent heat of fusion of ice is how much? 3.34 into 10 power 5 joules per kilogram. So this is a way to express huge numbers. Yeah, आप लोग ने previous standards में maths के अंदर exponents के बारे exponents नाम के lesson के अंदर सीखा होगा. So उस lesson में आपको already पता होगा कि ये notation का actual value कितना होता है, right? So it's a very huge amount of heat energy, correct? आगे देखते हैं. This heat energy is used up in changing the state of solid substance by overcoming the force of attraction between its particles. What was happening is, in solid state, the particles were closely packed to each other and they had some force of attraction between them. So when you were applying heat energy to it, what was happening was, it was like breaking down the force of attraction between these two particles, leading to more separation of the particle. Particle क्या हो जाएगा, दूर हो जाता है, right? So once these particles are separated from each other due to application of heat energy, the change of state takes place, and therefore solid gets converted into liquids. Moving ahead. Okay, so is ice at 0 degrees Celsius is more effective in cooling a substance than water at 0 degrees Celsius. So if you talk about ice at 0 degrees Celsius and water at 0 degrees Celsius, which will be having more lesser temperature? It is ice. Why? Because ice will be first taking, when ice is supposed to cool something, first of all, it will take its latent heat energy of fusion and then it will be converted into liquid, and then it will be brought down into its temperature will rise more with time, with if you keep it in open room temperature, right? Yes or no? But when you talk about water, what will happen is, water is already fused, it is already converted into liquid, so we won't have any latent heat energy of fusion over here taking place. It will simply absorb the temperature, leading to decreasing the temperature of the other substance from where the temperature is absorbed by the water, and then water simply rises its temperature. So when you talk about ice, ice will first be taking the latent heat energy of fusion and then it will be taking the rest of the heat energy. But when you talk about the water, water will simply take the heat energy from its surrounding. And therefore what we can say is, ice is more effective in cooling as compared to water. I hope so you have understood it well. What happens is, for melting, each kilogram of ice takes its latent heat of 3.34 into 10 power 5 joules from the substance and hence cools the substance more effectively. Okay, आगे देखते हैं. A piece of ice held in our hand feels very cold. अगर हम लोग एक piece of ice लेते हैं, हम लोग के हाथ में रखेंगे, what will happen is we'll feel it very cold. But on contrast, what happens is it takes latent heat फ्रॉम आवर हैंड. ये हमारे हाथ से लैटेंट हीट एनर्जी को लेता है, राइट? हमारे हाथ में जो गर्मी होती है उस गर्मी को एब्जॉर्ब करता है, एंड ये एब्जॉर्ब करने के बाद जब उसको अपना लैटेंट हीट मिल जाता है तो वो पिघलना शुरू होता है. इट स्टार्ट्स टू मेल्ट डाउन. आगे देखते हैं. लेट्स टॉक अबाउट लैटेंट हीट ऑफ वेपराइजेशन, एंड मोस्ट प्रोबेबली that's also easy for you students to understand if you have understood latent heat of fusion properly. Okay, so let's take in another example. We have water and liquid state in a beaker. Okay, we'll have some water in a beaker and we'll suspend it with the thermometer. And now what we'll do is we'll try to raise the temperature by heating it up. So latent heat energy of vaporization में क्या होता है? Once you start to heat up slowly, what will happen is that at reaching a temperature of 100 degrees Celsius, 100 degrees Celsius, Now the temperature will no longer increase. Rather, what will happen is the change of state of matter will take place, and the liquid water will be converted into gaseous vapors. Right? Okay. Let's see. So we'll keep on stirring it well. So as the temperature rises gradually until 100 degrees Celsius is reached, at 100 degrees Celsius, the water boils and starts changing into steam. Barabar? So 100 degrees Celsius approaching what will happen is that the water will be start boiling, boil होना शुरू हो जाता है, and just because of that, what will happen is it will be getting converted into what? Into steam. आगे देखते हैं. As the heat supply is continued, there is no rise in temperature. 100 डिग्री सेल्सियस डिग्री में पहुंचने के बाद अभी टेम्परेचर और बढ़ेगा नहीं, और इस चीज की वजह से जो थर्मोमीटर रीडिंग दैट विल बी कॉन्स्टेंटली waiting, or it will be simply sitting at 100 degrees Celsius. Okay, moving ahead. The particles of water attract one another with certain forces. These forces of attraction hold the water particles together in the liquid, and the heat supplied to the water during boiling is used to overcome the forces of attraction between water particles so that they become free and change into gas. Now we know that when you talk about liquids, the particles are farther from each other, but not too much, right? But still they have some force of attraction between them. So once we are like applying heat energy to these particles, what will happen is the force of attraction is broken between them, and the particles will move more further away from each other, leading to the formation of gaseous state. We have seen that the particles of gaseous state are like they usually are very far away from each other, right? Okay, so that is because of the heat energy that we have supplied to the system, to the solution. So that amount of energy in which that amount of energy required to convert unit volume of liquid into gaseous state without changing its temperature is called as latent heat energy of vaporization. Okay, so this latent heat does not increase the kinetic energy of water particle, and hence no rise in temperature takes place. Let's see, और आगे हम लोग क्या है. These forces of attraction hold the water particles together in the liquid state. Let's see again. The latent heat of vaporization of a liquid is the quantity of heat in joules required to convert 1 kilogram of the liquid at its boiling point to vapor or gas without any change in temperature. हम लोगों ने अभी जस्ट यही सीखा है कि अगर हम लोग के पास कोई भी मटेरियल या कोई भी लिक्विड अगर उसके बॉइलिंग पॉइंट हम लोगों ने पहुंचा दिया है, और बॉइलिंग पॉइंट में पहुंचने के बाद टेम्परेचर अगर बढ़ने वाला नहीं है, बट स्टिल हीट एनर्जी लेकर वो कन्वर्ट किस में हो रहा है, तो गैसेस में कन्वर्ट हो रहा है. So the amount of energy to convert that 1 kilogram of liquid into gaseous state will be called as the latent heat energy of vaporization of that liquid. आगे देखते हैं. The latent heat of vaporization of water is 22.5 into 10 power 5 joules per kilogram. That is the amount of latent heat of vaporization required for water to get 1 kilogram of water to get converted into um, a gaseous state at its boiling point. The next thing is boiling point of water is 373 kelvins. तो अगर हम लोग उसको यहाँ पे देखें डिग्री सेल्सियस में देखें तो कैसा होता है, तो 100 डिग्री सेल्सियस इज इक्वल टू 273 प्लस 100 इज इक्वल टू 373 केल्विन्स. राइट, हम लोगों ने ये कन्वर्जन ऑलरेडी देख चुके थे प्रीवियस स्लाइड्स के अंदर. करेक्ट. लेट्स सी आगे देखते हैं क्या हमको मिलता है. The burns caused by steam are much more severe than those caused by boiling water. Is this true? Right? So boiling water doesn't has latent heat energy of vaporization. But when you talk about steam, it has latent heat energy of vaporization. And therefore, steam contains more energy as compared to boiling water. And therefore, steam tends to like imply more damage to our skin rather than boiling water. Both of them are at 100 degrees Celsius. When water changes into steam, it absorbs latent heat. Steam contains more heat in the form of latent heat than boiling water. The same thing I have already explained to you right now.